So you can test it before you buy it. I'm joking. Yes, it's open source. You can throw basically vulnerability, your threat modeling, your threat attack description, and all of the vulnerability that you have, and it's going to spit basically the attack vector and the enhanced description. And we want to be able for everybody to start talking about this. And the only way we could do it, open source it. Have a play about it, capture the link, the book, explain the journey, the methodology, and the data set that we used, that I've used to actually guide the research team. This is a shared research right now with the North Carolina University. We have a couple of PhD working on it, plus Yahoo team. And we're going to make a little bit of this open source available. So we're going to enrich, and basically we rewrote the entire MVD to fill the gap of that 50% of vulnerability that weren't basically categorized with methodology of attack. And fundamentally what we did is, can we create a data set of common vulnerabilities similar to OWASP top 10 that enable us to characterize the vulnerability in the MVD or whatever we can see? And then we said, in the National Vulnerability Database, or all of the vulnerability that we have available, what are the common characteristics? If you look at on the right, they're fairly distributed. So we don't see any pattern appearing. So we start looking at, is the pattern between different years going to change? Yes, we start seeing the distribution of problems start changing. Cross-site scripting is basically slowly going away as a problem. Remote code execution is staying, but denial service is slowly going away. And then we answer the very important question: can we apply this to ransomware? So we took zero-day vulnerability, or the well-known vulnerability that's been disclosed, bug bounty, ransomware attack, and say, out of this, what are the trending, what are the patterns that are more frequent? And at this point, we start seeing pattern emerging. Remote code execution is something available and reachable from external and from remote. Can I execute code? Yes. Buffer overflow, can I breach basically gap in memory that's going to enable me to move between programs and maintain persistency? By the way, all of this data is available to play. So we publish all of the data behind this intelligence on the website. So go and play with all of the data set we have available through our CTI. But fundamentally, we start seeing as well, 0-day was probably, remote code execution is very apparent throughout all of the years, throughout 0 days. And then we start asking the question, ransomware attacks. First of all, what is the frequency of ransomware? And can you notice who has the biggest attack surface? Which vendor has the bigger attack surface? Microsoft. Why? Because everybody's using it. Everybody has a Microsoft product. So as a ransomware attacker, I'm going to develop the version for Arch Linux, or I'm going to develop the version for Microsoft Windows. So programs and these are actually, we actually embedded that in EPSS. So if you have a particular program or if you have a particular version, those tags are actually part of the EPSS dataset, and we use the same logic as well here. But I want you to focus on the right side. Again, we start seeing the memory corruption and the remote code execution as pattern appearing. And over and over and over. So basically we took this and saying, can we use this as a prediction scoring or as a way to determine which threat actor is using which methodology, and created basically a data set that enable us to predict which vulnerability will lead into a ransomware or into a potential exploitation together with all the other factors.